Scaling groups or ACGSs. So what is a scaling group? In real life, the load on your servers or application can change. The more popular you are, the more visitors you will have, the more your load is likely to increase. And so we've seen that in the cloud, you can get rid or create resources quite quickly and quite easily. The objective of an auto-scaling group, or ACG, is to act on the number of instances by scaling our infrastructure in relation to load increases or events linked to the use of our machines. And so we'll have the role scale out, which will allow us to add AC2 instances in order to face a load increase. Scale in, which will allow us to reduce the number of instances to adapt to a much smaller load. Ensure that you have a maximum number of machines and a minimum number of machines based on demand and load. An interesting feature of scaling group is that they allow you to automatically add instances to a load balancer and when the load increases or decreases. Let's see how this is illustrated. We have our scaling group, or ACG. We'll define a minimum size for our ACG. You have a normal size, that is to say the desired capacity for our services to work properly. We'll have a maximum size and number of instances that we'll be able to add and that we'll have defined beforehand to be able to face a load increase. ASGs have the following attributes. They have a launch configuration. The launch configuration is an AMI plus an instance type, user data in AC2 for application installation, and EBS volume or volumes, and security groups, SSH key pairs. Next, we can define the minimum size and maximum size, as well as the initial and desired capacity for our ACG. We'll be able to fill in information about the network, information about the load balancer, define a scaling strategy. What triggers will reduce the number of machines and what trigger will increase the number of machines. We'll use scaling groups alerts. They are used in CloudWatch and allow us to size a scaling group using alerts. To put it in perspective, we have our ACG here with its instances. We have an alert that will trigger the creation of 2 new instances according to the parameters we have defined. We can define it on a metric, on the CPU, the RAM, or the number of users that connect. These metrics are calculated for all instances of scaling groups. And based on the alerts, we can define a policy for reducing the number of machines, scale out or scale up, or a policy of restriction of reduction of the number of instances, scale in. The new rules of scaling up. It is now possible to define better rules than those existing on AWS AC2. Average CPU usage can be targeted. The average number of requests received by the load balancer for an instance can be used. Rules can be defined in relation to the average outgoing network traffic, incoming network traffic. All these policies are easy to set up and maintain in AWS. Now about customization of metrics for scaling. We can also scale our infrastructure based on metrics, CPU, RAM, number of users, as I told you before. We can send custom metrics from an application in our AC2 instance to CloudWatch with the putMetric API. As a result, our application will send information to CloudWatch, which can act on the scaling group or ASG. We can create CloudWatch alerts to react with low or high values, maximums, activity, peaks, or faults. We can use the CloudWatch scaling policy as a policy for our ACGs instead of the ACG specific policies. So we'll be controlling our ACGs directly with CloudWatch. So this is a tool that will be very interesting to use later on this course. Let's go over all the notion we have seen in this lesson. We have seen that this scaling strategy can be based on CPU, network, and other parameters, and can even be based on custom metrics or scheduling. For example, if we know the habits of our visitors. IUMs use never launch configuration or launch templates. To update a SAAM, a new launch configuration or launch template must be created. IAM roles attached to SAGs will be assigned to AC2 instances, so the rules we apply to our users will be applied to the security group of our instances, and the ACGs are free. We only pay for the downstream resources, that is to say the instances and the consumption according to the type of instance we use in our infrastructure. Having instances in an MSA is to have the guarantee that if they fail, they will be automatically recreated by the MSA. The ASG can therefore stop instances if the load balancer tells it to, and therefore replace them. In the next lab, we'll see how to set up an ASG and how to define rules.